Alright, this is section 4.1 work, and so we're going to focus on studying, obviously, work. So work, you probably think of, you go to a job and you do something to earn a paycheck, and physics has a really different definition of work. And work is simply a force applied through a distance. And hopefully you remember from the last section that force is just basically something that is a push or a pull. So if you push against a desk, and even though if you push it as hard as you can and you're sweating and you've burned thousands and thousands of calories and the desk doesn't move, we technically in physics say that no work has been done. So in physics, something physically has to move in order for work to be done. So even though you've went out there and you've tried to push a car for hours and it never ever moves, technically in physics no work has been done. Okay, we have two specific conditions for work to be satisfied in order for it to actually be done. One, as I just said, it has to move. If it doesn't move, work hasn't been done. And then the other thing is that it has to be done in the same direction as the applied force. I'm going to cut away here for a second. I'm going to come on camera, actually. You're going to see me. And I'm going to show you a actual visual of this, showing you where work has been done and has not been done. So we'll be right back.
Alright, I'm going to show you a visual of work actually being done. So if I have a book here, and let's say I'm picking it up from this desk, or I'm picking it up from the floor, the book is going to go straight up. So the direction of the force is up. And so the direction of the book is also up, right? So, force up, direction up, work is done, okay? Because they're both in the same exact direction. Now, let's say, though, I decide to pick up the book, but my direction of my force is this way. I decide to carry it, like I pick up my books from my locker, pick it up, and I decide to carry it to my class, okay? So, the force is being held this way, and my direction is this way. So force this way, direction this way. So the force and the direction are in two different ways. So that means that no work is being done, because the force and the direction have to be in the same way, rather up and up, side and side, down and down, other side and other side. If they're not in the exact same path, then work is not done according to the physics definition.
So from the video, hopefully you saw that when you do certain things, like for example carrying the books, there are times that you do work and there are times that you do not do work. And so I've kind of explained here in actual word terms on a slide what I just showed you about carrying books, and that when you hold it a certain way. So here are the sorry about that, word explanations of what I just showed you. So if you need to pause, there you go, but we'll just kind of go through this. Now, one last thing about when work is done. The other thing is that if you're pushing something along the desk, again, work is done, but it's only done as long as you keep your hand in contact with it. So if I were to decide to take a book and give it a push across the table, I would only be doing work for as long as I would keep my hand on the book. So just keep in mind with that too, that you have to have physical contact with the object too. Throwing an object or pushing an object, you have to keep your hand in contact or in contact with the object the entire time. Alright, we do have a work equation. The work equation is W equals FD, which is the work. Work is measured in joules, which is a unit of energy. We'll talk about energy more here in a little bit. And so that's equal to the force. Force, as always, F is measured in newtons, times distance, how far you moved it, and of course distance we measure in meters. So we'll do some practice with that. So again, before we even read the problem, we know this is a work equation, so we're going to use this equation, W equals FD. A force of 75 newtons is exerted on a 45 kilogram couch, and the couch is moved 5 meters. How much work is done in moving the couch? Okay, so we need W, we need F, we need D. So we're looking for things. 75 newtons, that's a force. So that's F. 45 kilograms. Well, W is in joules and D is in meters, so 45 kilograms does not help us at all. That's extra stuff we don't need. So we have this last number here, 5 meters, that's our distance. So now you're ready to solve for work. W equals 75 times 5. So we just need to take our handy dandy calculator. 75 times 5 is 375. Okay. And so it's W, so you would label it in capital J for joules. That's the abbreviation. Okay. All right. So there's the first one. Second one, again, you're going to use your W equals F times D. W, F, D. So a lawnmower is pushed with a force of 80 newtons. If 12,000 joules of work are done when mowing the lawn, what is the total distance the lawnmower was pushed? Again, we go through, they give us 80 newtons. Newtons is a force, so 80 newtons. 12,000 joules of work, 12,000 joules. So work is 12,000 joules. So the only thing I do not have is distance, which is good because they're asking for in the question, what's the total distance? So 12,000 equals 80 times D, divide by 80 on each side. 12,000 divided by 80 is 150. So D is equal to 150 and D is in meters. So that's how you would solve for a distance problem. Last but not least, still W equals FD. W, F, D. The brakes in a car do 240,000 joules of work in stopping the car. If the car travels a distance of 50 meters while the brakes are being applied, what is the total force of the brakes exerted on the car? So here we have 240,000 joules. So there's your work. They give you 50 meters. So there's your distance. So here's an example of where we're going to solve for force, which is good because they say what is the total force. So 240,000 equals F, I don't know, times 50. So that means that each side of the problem you're going to divide by 50. So 240,000 divided by 50 is 4,800 for your force, and forces are always measured in newtons. So there are all of our work problems. So we went through one, how to solve for each variable. And so you guys will end up practicing some on your own. Okay?
One time exclusive. Come on, is it worth it? Let me work it.